I'm a developer advocate at Google Cloud, where I focus on Google Kubernetes Engine and open source Kubernetes. And today I'm excited to be with experts from the Cloud Storage and GKE teams to talk about a new storage integration that's really interesting for AI/ML workloads. Team, would you like to introduce yourselves? We'll start with Akshay.
Hi, everyone. Thanks, Kathleen. Hi, everyone. My name is Akshay. I'm a product manager in GKE, and I'm specifically focused on making data and stateful apps run better with Kubernetes and GKE in particular.
Welcome, Akshay. Marco?
Hey, Kathleen. Hi, everyone. Excited to be here. My name is Marco Abella, and I am a product manager on the cloud storage side.
And Jashin?
Hello, everyone. My name is Jashin. I'm a software engineer on GKE Stateful Workloads team.
Welcome, everyone. I'm so excited to have you here. And I was telling you all before we got started that I've recently had an experience where I was talking with someone about a problem they had, and Cloud Storage FUSE was the answer. So I'm really excited to learn more about it. Can we start off with what is Cloud Storage FUSE?
Yeah, sure. Absolutely. Cloud Storage FUSE, or sometimes referred to as GCS FUSE, is a way to mount a cloud storage bucket as a local file system. So what we typically see in AI/ML workloads is that cloud storage is a common choice to store and access training data, models, and checkpoints because of the scale, simplicity, affordability, and performance that cloud storage natively provides. Now, while some AI/ML frameworks have libraries that natively support object APIs, others simply require file system semantics, or customers choose to use file system semantics for a consistent experience across hybrid and multi-clouds. To overcome this, what developers typically have to do is they have to instrument their training code with specific logic to first copy the training data from cloud storage to local disk. And this is where Cloud Storage FUSE really helps. It's in maintaining this portability. So with Cloud Storage FUSE, objects in cloud storage buckets can be accessed as files mounted as a local file system, providing a frictionless experience for applications that need file system semantics while maintaining these native benefits of cloud storage. The second benefit is really around performance. So what we typically see is for customers that use cloud storage as their source of truth, but they need to consume data via file system semantics, as I mentioned before, developers typically implement complex logic to first copy this training data from a cloud storage bucket to a local disk. The trade-off with this is that there are higher training costs due to compute resource idle time. While you're waiting for the data to download, your expensive accelerators, which are typically used in ML workloads, which are your GPUs and TPUs, they're sitting there idle until the files are downloaded in order to begin making forward progress. With Cloud Storage FUSE, again, the machine learning framework just sees these files as if they were local, and the data is just streamed directly as if it were local, eliminating this resource idle time by giving the GPUs direct access to this data.
This is really exciting because, when you dive into storage, it can be complex to figure out exactly what kind of storage you need to use for what different purposes and how that connects with all of the different things that you're running your applications in. It can all get complicated pretty fast. But storage buckets are a really interesting form of storage that the cloud has been very popular in the cloud because they're a simpler way to interact with storage, and seeing a way to connect that with workloads running in Kubernetes is something that I find exciting.
One thing I want to add here, Kathleen, very well said. I think what we also hear from customers is usually storage is something that just works. Customers think of it as essentially an add-on to their application. But with AI/ML applications, we're seeing a lot of attention being brought to focus and how do customers ingest their data in efficiently. Because as Marco said, a lot of these GPUs and TPUs are expensive resources. So getting the data in efficiently is really top of mind for customers. What was pretty much a second or third order decision is becoming really top of mind. So that's why a lot of customers are excited about this.
And these workloads also often require a lot of different resources all at the same time. Using them all efficiently is essential. I hear a lot of talk about efficiency in using hardware and using resources in AI/ML workloads. When I talked with one of my teammates about this, they mentioned that Fuse has actually been around for a while. So, what's interesting about it now?
So great question. While Cloud Storage Fuse has been around for a while, it was never a Google supported product. It was just open source contributed and open source community contributed and supported. And it was never intended to run production workloads. So as part of this, what we have done is that we have taken ownership of the project in order to make it a first party Google supported solution. As part of this, the main focus has really been around stability and being able to recommend it for production workloads. So as part of this, we spent a lot of time and effort on making this a very stable product. A lot of work went into that, fixing some very complex bugs that were uncovered as part of some long duration and large scale tests that we did, and then validation using actual ML models such as the VIT Dino model and the ResNet model to ensure its stability. Again, the main focus here has really been around stability and that this is now a Google supported product.
As someone who also works in open source Kubernetes, obviously Google Cloud has Google Kubernetes Engine, which makes use of the open source project. And we have a lot of engineers that contribute directly to the project. I'm excited to see another project getting some support. So many customers want to use open source projects because there's so much that they can do for you. There's so much range that open source projects can cover. But it's exciting to see Fuse get picked up so that GKE users can use cloud storage more efficiently, like you said, with greater stability.
As part of this, we worked with Akshay and Jashan here on the GKE team in order to provide a really cool turnkey integrated offering as part of GKE, which is brand new, which is what we're going to deep dive a little bit more on as part of this.
Exciting. I definitely want to hear more about that. How is this integration accomplished? I think the common terminology for it is container storage interface, or is that right?
Yes, Kathleen, that's right. It's the container storage interface. It's a Kubernetes extension where applications can communicate with storage services. So that was a natural extension point for us to use for this integration. But just to give users or our customers like what this means for them is one of the themes or the design themes we really wanted to follow is just to keep it really simple. And the simplicity is across two modes of operation, the day one mode of operation and the day two mode of operation. And I'll double click on each one of that. So in day one, a lot of customers, if you didn't, before this integration, you had to manually install a binary. Sometimes you needed privileged access because cloud. So customers had to muck around a lot by SSHing into a container and kind of really playing around a lot with the internal system properties. What we have done is we have created an out-of-the-box GKE CSI driver for Cloud Storage Fuse. So you just have to enable it. That's it. All the installation and the availability to your applications is fully managed by GKE. And the second part in the day one operations is also the fact of authentic, because yes, we wanted to keep it simple, but we also wanted to make it capable. And one of the big requirements from customers is to make sure that they have a good way to fence down how pods can access storage buckets through IAM-based authentication. So that's another piece where we invested in by using workload identity to make IAM-based auth really easy and turnkey so customers can have fine-grained permissions on how pods can access their cloud storage buckets through the file interface on GKE. So that's on day one. And this on day two, what are the themes we followed there to do a lot of underneath the hood work to make life simple for customers? We heard from customers with Cloud Storage Fuse before they had this managed turnkey CSI driver from us, that there was a lot of correlated failures where one Cloud Storage Fuse driver gets impacted by out of memory. It kind of impacts every other pod in the in that particular node. And there's also the life cycle of patching and managing patching for CVEs of the Cloud Storage FUSE driver itself. So all of that is now managed by GKE. So you should be covered on day one and day two to simply access your Cloud Storage FUSE buckets via the file interface. And in a pod spec, all you need to do is tell us your Cloud Storage bucket. We'll make the rest happen.
What I like to usually say about this is that it's a way for a user to mount a bucket within a GKE construct, and they don't even really need to know what GCS FUSE is. They just use the familiar Kubernetes API and the YAML spec, which we'll cover later. Just show the bucket name that you want mounted, and you really don't even need to know what GCS FUSE is. So it's pretty cool.
Like I was saying earlier, the storage considerations with Kubernetes can really get complex. So things that can simplify that process, I think, are always in high demand. I remember in the early days of Kubernetes, and also when I'm talking to folks who are just learning Kubernetes for the first time, one thing I always like to point out is that Kubernetes is designed to be distributed computing. It's a way for you to run your applications across a whole bunch of different machines. And that causes all of these problems when it comes to storage, because storage data has gravity. The closer you are to your data, the better performance you're going to get when you interact with it. And there's all sorts of ways that people try to make data match the way that they're running their applications in Kubernetes. And buckets are a really exciting form of that, because buckets are really designed for distributed computing in a sense, in that they're designed for the cloud. They're a little bit more flexible. They're a little bit more streamlined to use in a lot of the kinds of use cases that you see in the cloud. So early on, a lot of storage providers were starting to come up with, how does our storage work with Kubernetes? And at one point, those storage drivers would get added to Kubernetes itself. And so every time you installed Kubernetes anywhere, you'd have all of them. Then we decided that was a terrible idea, because not everybody needs all of the different storage drivers, and also maintaining them as part of Kubernetes caused all kinds of problems. So these days, it's more common for storage drivers to, you were saying, be their own projects that then users have to deal with. They have to go in and install it if they want to use it, and it causes all sorts of friction. So what the team has done here is taking the solution that makes a lot of sense for a lot of use cases that customers of GKE have, and then integrated it, making the whole thing really streamlined. Is that a good summary?
Yep, that's a great summary. Absolutely. We want to make customers' lives as easy as possible.
Awesome. So I talked a little bit about why storage drivers are interesting historically with Kubernetes. You've talked a little bit about why it's interesting to your users. Someone out there listening to this today, if they're considering use cases in Kubernetes where they might need storage, why should they consider Cloud Storage FUSE?
Yeah, that's a good question, Caslin. I think the biggest reason we hear from customers is portability. So the file access pattern is quite a standard. It's used on-prem, it's used in other clouds. So data scientists actually use the file semantics pattern in their Jupyter notebooks and code quite often. And when they're using, and let's say there's a customer who says, hey, I actually want to use some of the TPUs that uniquely GKE has. They don't want to change their code too much, because let's say they're all coming from on-prem and they're just using file semantics. And it should just work in the cloud on GKE without you having to change your code. And that is really big, because what you can then do is you gain a lot of portability and a lot of agency on how to really run and utilize some of the really powerful accelerators here on GKE and Google Cloud. The second use case we hear is a lot of customers run AI/ML training jobs on GKE, and they're massively parallel. And what Cloud Storage FUSE provides them is incredible aggregate throughput. So as these jobs scale out and try to download data all concurrently to access and process, GCS is an amazingly scalable product to give them as much throughput as they need. So it is really capable as a backend storage for AI/ML. So they really like that they can use file with GCS. It's a great combination because of the ease of use on portability and the performance. And then, of course, as Marco alluded earlier, there are techniques where, because you don't have to wait for the full file to download, you're pretty much accessing the data like you are a file. There's faster model startup times. And there are additional use cases where people also write back some of the checkpoints to GCS. GCS is really cost effective as well to store your data. So a lot of these models, what they do is just to make sure that they save their state so that it can be restored during any failure event. Customers do write checkpoints back, and GCS Fuse to the CSI driver fully supports writing back checkpoints to GCS.
Interesting. This is reminding me, at the beginning, I mentioned that I had a conversation with someone recently about a problem that they had where we thought GCS Fuse or Cloud Storage Fuse could be a good solution. And I believe, I don't remember exactly what we were talking about, but I believe the problem that they were facing was that they had multiple applications that needed to be able to read the same data. And so this seemed like a really good solution for that. I think they might have even needed it across regions,
Definitely.
but I'm not sure.
For that use case, for sure, Kathleen, I think what we see is the beauty of GCS is it can support many concurrent readers, aggregate throughput to back it up. So that is a great use case for GCS.
Awesome. So that's one that I encountered recently. And I'm excited to see all of these different ways that folks can use Fuse to solve these kinds of problems in Kubernetes. Like I said, the Kubernetes applications and storage has always been an interesting area, and buckets seem like a really interesting solution there. So these are some really interesting use cases for Fuse. I'd like to hear a more specific one. Do you have any specific customer use cases that you could talk about?
Yeah, absolutely. So I'll cover here a use case of one of our really cool, fast-growing customers called Codeway, which develops mobile applications. And specifically, this is going to talk about the simplicity aspect that we were talking about before, and also the faster model load-up time. Codeway has built a mobile application called Boy, which is an AI-based avatar maker. What that means is that I upload a certain amount of pictures of myself, and then I prompt it to make me look like a Greek god, for example. So in this use case, what is happening, this is very interesting, is to start with, is that a user uploads around 10 to 15 pictures, which gets saved in a cloud storage bucket. Then what is happening is that a model training process begins on GKE using GPUs, where a specific model is created for each individual user. And once that model is generated, this is being done really fast in real time. Once that model is generated, it's saved again in a cloud storage bucket. And then this is where the inference process kicks in, which is what GCS Fuse on GKE is used for. What happens is that this model is now loaded and mounted using the GCS Fuse CSI driver. And now this is where a user prompts saying, hey, now make me look like a Greek god. And as part of this, the model is mounted as if it was a local file system, making it much, much faster to go ahead and spin up that inference process, which is very important because this is the wait time from the user perspective. Once that image is generated, it's again outputted to a cloud storage bucket and then served back up to the mobile app via a CDN. So again, in this case, it's simplifying this end-to-end pipeline while speeding up the inference time as part of that fast model load.
It makes a lot of sense seeing this use case, how the Cloud Storage Fuse driver makes sense in AI/ML use cases for making those inference models more efficient to access and faster. One question that I have is, why wouldn't a user use something like file storage for these types of use cases?
Yeah, I can take that, Kathleen, because we get that a lot from customers. I think file store is a recommended fully managed NFS-based storage offering. File store also has a CSI driver, so you can access it easily through GKE. But typically, we see file store used for applications that need some of the NFS capabilities like concurrency locking, where there's multiple writers. So that you want to ensure the consistency in writes. Those are applications like SaaS applications, like think of Google Docs where there are multiple readers and multiple people writing on the same docs. You want to ensure locking and consistency. But what we're seeing here is, so it works great for that use case, but there was a lot of other customers like the AI/ML and the machine learning use cases where they don't need that concurrent writes. Even writing back to cloud storage is just a checkpoint, or just writing an object back, as Marco shared in this use case. So there's no need for that kind of use case. So the customers want it like cloud storage is where their data is stored anyway. And can I just have a file layer in front of it? So think of it as a much lighter abstraction, Cloud Storage FUSE, than file store. It doesn't have all the capabilities that file store has, but it does have the simplicity that is helpful in AI/ML use cases.
Interesting. So we have Cloud Storage FUSE, which gives us access to cloud storage buckets from workloads running in Kubernetes in this case, as we're talking about. And it has all of these potential use cases around efficiency and speed and AI/ML use cases, and in cases generally where you have a lot of readers. And it's lighter weight than if you were to use file storage. I'd love to hear more on the details of how this works.
Absolutely. I would like to dive deep into the CSI driver architecture. Let's start from the most right side. On GKE control plane node, we deploy an admission webhook controller, and everything starts from the webhook controller. The webhook controller will monitor all the incoming pod creation requests. Whenever it detects the necessary pod annotation, it will inject a sidecar container into the customer pod. And Cloud Storage FUSE instances will run inside the sidecar container. The Cloud Storage FUSE is used to translate the bucket to a virtual file system so that the bucket can be mounted as a regular volume onto the node VM. Then on each node VM, we also have a site driver node server running. So the site driver implements the set spec to allow Kubernetes to mount or unmount volumes. So whenever a customer pod requires a volume backed by a GCS bucket, the kubelet will call the CSI driver to mount the volume. And then CSI driver will create the mount point and obtain the file descriptor that represents that mount point. And then the CSI driver will pass the file descriptor using a socket in an empty to the sidecar container. And on the sidecar container side, the sidecar mounter will be the entry point of the sidecar container. And it will get the file descriptor and launch GCS FUSE instances. Whenever the GCS FUSE instance starts to serve the mount point, the connection is done. With this design, the sidecar container does not need to be a privileged container. Only the CSI driver pod requires the privilege to open that FUSE device on the node VM. With this design, we got several advantages. So first, we are trying to solve a problem when in the traditional CSI driver design, all the FUSE process ran inside the CSI driver. The pain point of that traditional design is that during CSI driver upgrade, all the FUSE process will be killed. So all the mount points will be disrupted, which will cause data corruption. Our design introduces the sidecar container mode, which solves this problem perfectly. Also, the sidecar container mode gives us an advantage, like the sidecar container does not privilege. We can support standard GKE cluster and Autopilot cluster. Also, the Cloud Storage FUSE can use the pod service account with GKE workload identity enabled, which provides users with a better security posture. Another benefit we are giving users is that users has flexibility to configure the sidecar container resource limit using pod annotation if they want a higher throughput from the GCS FUSE. So let's talk about the user interface. Marco, yeah. So this is the user interface we are promoting, which is called CSI Ephemeral Inline Volume. So traditionally, we have PV/PVC as an interface for customers to configure volumes. But with this interface, the lifecycle of volumes backed by the bucket is tied with the pod lifecycle. So after the pod termination, there is no need to maintain independent PV/PVC objects to represent the volumes in your Kubernetes system. So it gives users the flexibility to consume a bucket without depending on any PV/PVC objects or storage class. On the right side, this pod YAML shows that you need to put some pod annotation to tell the webhook controller, okay, this pod consumes GCS FUSE, and you need to specify a service account. And then on the volume part, this is a real simple example showing how you can put your bucket name as a part of the inline volume. And of course, we also support static provisioning as known as PV/PVC pattern.
I just wanted to make one point why the previous pattern is so common, and this is amazing work from Jiashin and team, is a lot of our customers on AI/ML are not storage experts. For them, even PV/PVC is a heavy abstraction. So Kubernetes experts, of course, know PV/PVCs. They've been there. It's been there a while. So we want to make that compatible. So we do support it. But the beauty of the abstraction of the interface here, which Jiashin is showing, is all you have to do in your pod is essentially tell us your GCS bucket, some properties of how much resource consumption you want the sidecar process to use, and your auth token. And that's it. That basically makes all of your data accessible to your pod. So this is the reason why even we went in a slightly different route, or actually have an alternative option for customers to get a very simple, easy to use interface without having any expertise.
And also to add on to that, the diagram that we showed in the slide before, which talks about how we implemented this with the sidecar, the webhook admission controller, that's all the hard work that we put in to make it a very simple solution for our end customers. Those are things that customers were having to worry about before, and different pain points from a complexity standpoint, security standpoint, scalability standpoint. And so that's where all our hard work went in order to obfuscate that from the user as much as possible.
And while we're interjecting, this is such a throwback for me because I was watching Kubernetes at the time when they first introduced local volume mounts and first started to create persistent volumes and persistent volume claims. And I feel like it's been a point of contention in the community ever since, because like you were saying, persistent volumes and persistent volume claims, they aren't the easiest thing to wrap your head around when you're new to Kubernetes. Even if you're familiar with storage, the way that Kubernetes thinks about storage as persistent volumes that you then need to create claims in order to use, it's a different way of thinking about how your applications use storage, on top of the different way that Kubernetes introduces on its own by kind of managing the application side of things while the storage side of things is separate. It's not a separation that most engineers have had to do if they're not using Kubernetes. So this is making use of a lot of those technologies that have been developing and then adding an extra layer of ease on top of it.
Yep, the PV/PVC is important as well for compatibility purposes, which I think Jiashin will get into next.
So conceptually, this makes a lot of sense and is very exciting in a variety of ways, but I'd love to see it in action. Could we see a demo?
Sure, I can show you a live demo. So let's start with a bucket. Here is a GCS bucket with some AI ML training data loaded. So here are some training data here. So let me show you how I can mount this bucket as a file system to a training workload. Here is a pod spec. So I'm going to create a Jupyter Notebook server. The first section is a service. I'm using a load balancer to access the server. And then here is a standalone pod. Nothing is fancy. I'm using the standard Jupyter Notebook server image here. And as I mentioned, I put the pod annotation here to tell Kubernetes, okay, this pod consumes GCS volume. Then I'm using the service account to authenticate with the GCS API. So this requires the GKE workload identity feature enabled on the cluster. And you can easily follow the documentation, the GKE documentation to set up the workload identity part. Here is the volume section. I'm using the ephemeral inline volume. Here is where I specify my bucket name. So if I deploy this pod and then switching back, here is my Jupyter Notebook server up and running. And as you can see, the GCS bucket is mounted as a file system. So if I click this folder, you will see exactly the same content you are seeing here in the bucket. And you can easily play around with the files as like regular files on your local file system. You can open the files, you can like create a new file, something like that. And also I have a training example here. The example will treat all the videos and images as local files. So I can directly click run all cells. And as you can see, the data processing starts immediately without prefetching or loading any images to the local file system. So all the data is streamed, and there's no gap between the data loading and the actual training job starts. Yeah, that's the lab demo part.
Awesome. Thank you very much, Joshua. I haven't done much AI/ML work, so seeing how these models kind of work when you're actually trying to use the data is really interesting to me. There are a couple questions remaining in my mind. You talked a little bit about how the CSI driver uses this really interesting sidecar kind of architecture to make it a lot smoother to use the storage buckets as your storage for your workloads in Kubernetes. We also now have in GKE Autopilot mode, which is now the default of mode of operations. I've heard a lot of users really interested in using Autopilot. One of the things that sometimes prevents users from moving their workloads onto Autopilot is that you can't run privileged pods on it. Can you run the Cloud Storage FUSE driver on an Autopilot cluster?
Yes. So we support Autopilot cluster. Thanks to the sidecar container mode design, we can run the sidecar container without any privileges. Yes, we support standard cluster and Autopilot cluster.
Privileged containers are such a security risk, which is, of course, why it's a best practice not to have them. So it's exciting to see the ways that folks are using to not run privileged containers. The more you can lock down your privileges, of course, the better off your cluster security is going to be. So I'm excited to hear that. Also, a question that I'm likely to get at some point is, does it work with Terraform?
Yes, we do support Terraform. So you can use Terraform to create a cluster with all the feature enabled, and everything will be managed by GKE.
This was a big request, and customers they thought they would stump us when they asked this question. But that was planned all along, so they were super happy to hear that it was integrated with the Terraform.
I'm glad to hear it. I do hear all the time, if it's not in Terraform, it doesn't matter. So I'm glad to hear that works. And one other thing, what versions of Kubernetes does this work with? Are there limitations there?
So we have backported the feature all the way to 1.24 clusters. So for existing clusters, you can follow the GKE documentation to enable the feature.
Awesome. So today we've learned about Cloud Storage FUSE, which is a CSI driver, which is automatically available in GKE clusters above 1.24. And it allows users to use cloud storage buckets in Google Cloud for their data storage for their workloads running in Kubernetes, which gives them the benefit of if you have a whole bunch of different workloads running in Kubernetes that all need to read from the same data, buckets work really well for that. And it provides some really interesting efficiencies, some speed for AI/ML workloads. Is that kind of a good summary?
Yes.
Nods. Yeah, I'll take it. So now that folks have learned about Cloud Storage FUSE, its basics, they've seen a demo, some of the use cases, where can they go to learn more if they want to try it out themselves?
Yeah, so as part of this now becoming a Google first-party supported product, we've also completely revamped documentation. So the easiest thing to do is to go to Google, just type in Cloud Storage FUSE. That will bring you to the landing page. And then from there, you can navigate to the specific documentation that is for a CSI driver.
Awesome. Docs are always in demand. I'll have to go check those out myself. Thank you so much, everyone, for being on today.
Thank you.